India's target of 30% electric vehicle adoption by 2030 is driving a massive overhaul of urban parking. Developers in cities like Mumbai and Delhi are converting deep subterranean basements into high-density charging hubs. But beneath these corporate offices and luxury high-rises, these concentrated lithium-ion battery arrays operate as highly unstable chemical hazards. The combination of high-voltage systems, confined underground architecture, and limited ventilation creates a distinct hazard profile known as the basement trap. In the rush to meet decarbonization goals, a severe, unmitigated threat has been positioned directly beneath billions of dollars in real estate. The primary risk stems from a failure state called thermal runaway. When a lithium-ion cell is compromised by damage or overheating, it triggers an uncontrollable, self-accelerating chemical chain reaction. This diagram details the self-oxygenation process. As the internal temperature spikes, decomposing cathode materials release oxygen directly into the cell. The fire feeds itself internally, bypassing the need for atmospheric oxygen. Because the reaction is self-sustaining and protected by an armored casing, standard water suppression fails to reach the core. Applying massive amounts of water can instead trigger secondary electrical shorts or accelerate the release of toxic hydrogen fluoride gas. Standard fire suppression systems and conventional firefighting tactics are structurally incapable of neutralizing this chemical reaction. An electric vehicle fire generates peak heat release rates exceeding 7 megawatts, with localized temperatures quickly surpassing 1,000 degrees Celsius. This exceeds the thermal limits of standard structural concrete. At high temperatures, moisture inside reinforced concrete's internal pressure forces the material to violently shatter, a process called explosive spalling. This strips the building's structural spine of its fire protection. The newly exposed steel rebar rapidly loses its ductility, warping and melting under the sustained heat. We have already seen the results of uncontained vehicle fires in multi-story parking structures, where intense sustained heat leads to total structural failure. A single isolated battery fire in a deep basement poses a high probability risk for total building collapse and massive business interruption. Standard fire extinguishers cannot stop this. First responders must deploy specialized heavy piercing tools and sledgehammers just to physically breach the battery casing. Recognizing the extreme severity of this hazard, draft amendments to the National Building Code and local municipal guidelines are moving to restrict or completely ban electric vehicle charging in basement levels. Operating these charging hubs under outdated assumptions leaves corporate asset owners and insurance portfolios fully exposed to catastrophic liability. Asset managers must commission comprehensive basement risk audits immediately. The transition to electric mobility requires strict isolation zones and dedicated extraction protocols to protect the infrastructure above.